So in unit 4, uh, we have a laser fiber optics concept in there. So based on that, we'll go for the fiber optics. Let me give you an introduction about the fiber optics here. Uh, so here fiber optics, which is going to be dealing with the light propagation, and where it is going to be propagating a thin glass fibers. Okay. So which maybe plays an important role in the field of communication systems, and transmitting the voice, television, digital data signals from one place to another place, like that. So the transmission of light along the thin cylinder glass, how it is going to be transmitting means here, that is the principle total internal reflection. So the total internal reflection is the principle. So which was demonstrated by the John Tidal in 1870, and the application of the phenomena which is related to the field of the communication, and which tried only from the 1927. And today the fiber optics are also extended to medical field. So whereas in the case of endoscopy and instrumentation of engineering for the form of optical sensors. Okay. So many sensors are there. So inside the human body, what is going to be happening? Uh, Easily, if you are going to be observing means here, the behind this, there is a technology. The technology is a fiber optics. So which could be going on by the principle of the total internal reflection. Okay. So let me give you the phenomena of the total internal reflection. What is the principle of the total internal reflection? So here the principle is that the basic principle of optical fiber is in the transmission of optical signals, which is total internal reflection. So when the light rays, which is a travel from the denser to the rarer media, denser to the rarer media means a glass to the air, uh, the refracted ray bends away from the normal. If it is coming from the air to the rarer medium to the denser medium, then the refracted ray which moves towards the normal. Okay. Please remember these two cases. When the light ray which is coming out from the denser to the rarer medium at the normal, refraction is going to be takes place, but the refracted ray which is away from the normal. Whereas if the ray which comes from the here rarer to the denser medium. So the case is that if it is moving towards the normal, okay. So this is the one of the most important objective bit. So the thing is that here uh, the angle of incidence, this one, angle of incidence means I. So which is greater than the critical angle. The refracted ray again reflects into the same medium. If it is greater than the critical angle, then the refracted ray again reflects into the same medium. So this phenomena is called the total internal reflection. That means the incident angle should be greater than the critical angle means theta c. C is the critical, theta is the angle, critical angle, I is the incident angle. If it is greater than theta c, then total internal reflection is going to be takes place. That means the reflected ray, which again reflects into the same medium. So the refracted ray bends toward the normal as the ray travel from the, just now I already discussed that which is coming out from the rarer to the denser medium, and the refracted ray bends away from the normal as it is travel from the denser to the rarer. So this is the case. This is at the normal here, the incident ray, which is coming out from the denser medium and which is incidenting at the normal, which makes an angle theta I, and the refraction is going to be takes place when the ray which is coming out from the one media to the another media and which bends and enter into the other media is the refraction. So the case is to be observed. So here you can observe that theta I equals to theta. Let the ray which is traveling from denser to the rarer medium. So that means the denser to the rarer means away. So the angle of incidence is I and the angle of refraction is small r. And we can be obtained from the Snell's law. Snell's law means mu equals to sin I by sin r. Okay. So n1 by n2 equals to sin r by sin I. So when the angle of incidence which is increased, the reflection is also going to be increases for a particular angle of incidence. When I equals to theta c, then the refracted ray travel along the interface of the two media. This is the interface. This is the interface. Interface means which is separating the two medias. Okay. So this angle of incidence, which is nothing but a critical angle, theta c. If it is greater than, then total internal reflection is takes place. So n1 equals to theta I means theta c na I means therefore sin theta c in place of theta I we are keeping it as a sin theta c equals to n2 theta. 90 degrees is there. So that should be theta c equals to sin inverse n2 by n. So you can go for that here when the angle of incidence which is greater than the critical angle, the refracted ray again reflects into the same media. This phenomenon is called total internal reflection. Theta E is less than the theta C. Then the ray refracts into the secondary medium. I equals to theta C, travel along the interface. I is greater than theta C, reflects into the same medium. So these are the cases. Okay. So shall we go for the another one? I will share you the PPT. So optical fibers. What is optical fiber? So this is working under the principle of total internal reflection. What do you mean by total internal reflection? Just now we discussed it. But the thing is that here, what is optical fiber? An optical fiber is an hair thin cylindrical fiber of glass or any transparent dielectric medium. Dielectric means resistance is more, which is not going to be conducts any current. So an optical fiber is what is the diameter here? Air thin cylindrical fiber, which is made up of a glass or any transparent dielectric. So here the fibers which are used for the optical communications, like waveguides, which is made up of transparent dielectrics. So nowadays, where we are getting the signals means here from very, and also we are sending the signal to the long distances. That means how it is possible by means of here, we are using the optical fibers. So these are the materials we are using to send the signals or to receive the signals from a very long distances. Okay. So most probably these fiber optics where we are using means in communication systems. Okay, na? Next, its function is a guide visible and infrared light over long distances. Okay. So, which is going to be functioning visible and IR, infrared light over a long distances, which can carry out the signal. Okay. Na? So, what is the structure of the optical fiber? So, you can see here, this is a optical fiber here. So, this is the core. First one is this is the core here. Inside, this is a glass material and a transparent dielectric medium is there. This one. So in this only total internal reflection is going to be takes place, and you are sending the signal. Okay. So on the core there is another jacket is there, that is the material is there, that is the cladding. This one is the cladding, and again this is a coating. This one, and this is the strength member. This one yellow color, and orange color, which is a outer jacket. Okay. So core, cladding, coating, strength member, and outer jacket. So let us discuss about the what is the core size is there. So core is the central tube, which is of very thin size and which is made up of optically transparent dielectric medium. So through this only the signal is going to be sending, or through this only we are receiving the signal. Just like how it is possible means by sending the light from the transmitter to receive. And what is the core diameter of this optical fiber means, which can be varies about the 5 micrometers to 100 micrometer. Micro means 10 power minus 6. Is it clear? 5 micro to 100 micrometers. Next, other one is there, uh, cladding, which is a outer optical material which is surrounded by the core, and which can have the reflecting index lower than the core. Okay. So which helps to make the light within the core throughout the phenomena of the total internal reflection. Okay. So by this total internal reflection principle only, the light, that means here the signal in communication system, whether you are transmitting or whether you are going to be receiving, that can be achieved by this core material only. Okay. Okay. Yeah. Next is the buffer coating. So the buffer coating, plastic coating, that is going to be protects the fiber, and which is made up of a silicon rubber, so that here there should be a flexibility there. If you are going to be bending or if you are going to be stretching, nothing is to be happened to the core material, and so that that's why here which is a silicon rubber, the typical diameter of this fiber after coating, which is 250 micrometers to 300 micrometers. Okay. So that is the case. But how it is going to be working means by the mean of total internal reflection. So here you can observe the case. The thing is that here this is the light ray, and which you are going to be sending uh, uh, through the transmitter uh, in a communication system here. So the light ray which is to be incidenting, and if the theta I value if it's greater than the critical angle, the total internal reflection, that means here in the same media means here which is a core here. Okay. So in this core only the ray, incident ray, which is going to be here internally reflecting in the same media, that means here multiple reflections is going to be takes place. Okay. So outside the glass here, this is the air media, total internal reflection is to be takes place like this. Okay. So when a ray of light travel from a denser to the rarer media such that the angle of incidence which is greater than the critical angle, the ray reflects back into the same media. This phenomena which is called total internal reflection, TIR. So in optical fibers, the ray which undergoes repeated total number of reflections. Okay. How many number of reflections is to be takes place means that is until it is going to be coming out from the other end of the optical fiber. Okay. Even if the fiber which is bends, but the ray which is taking out the data or taking out the signal through this material. Next, classification of optical fibers. So, how many types the optical fibers which was classified, which is in two categories based on the number of modes. Okay. In this number of modes, SMF, single mode fiber, multi-mode fiber. Here you will get one essay question in examination point of. So single mode fiber is there, multi-mode fiber is there. Other category which is related to the refractive index. First one is the number of modes, single mode, multi-mode. Whereas in the refractive index, step index optical fiber, graded index optical fiber. So here only you will get the questions. Step index and graded index. So we can go for the on the basis of the number of modes, uh, single mode and multi-mode fiber. What is a single mode fiber? So single means one. So one mode can propagate through the fiber. Single mode means only one mode can propagate. You can see here. Only single one which is coming out. See here. This is the single one. Only one mode. Okay. Which has a small core diameter and high cladding diameter up to 70 micrometers. So what is the refractive index of the core and cladding, which is the difference is very small here for single mode. And this is only suitable for long distance communications, single mode. When the light is going to be passing through the SMF, which is a laser diode, not an ordinary diode, not an IR, which is a laser diode. The light which is passing through the single mode is laser diode. Okay. And which may be used for a long distance communications. Whereas multi-mode fiber, it allows a large number of modes for light which can traveling through. A large number of modes. You can see here. A blue color is there, one mode. A green color is there, second mode. And purple color is there. This is the third one. So that multi-mode, three modes are passing through it. Here only red color means single mode, only one is going on. Here three, blue, green, purple. Okay. So here it allows a large number of modes for light which is traveling through it. So what is the core diameter? 40 micrometers, which is more. And cladding is 70 micrometers. Okay. So the relative refractive index difference is also larger than the single mode fiber. Okay. Which is larger than the single mode fiber. And there is a signal degradation due to the multimode dispersion. So why it is happening here? Because of there is number of modes which are passing through it here. That's why here the signal which is going to be degrades due to the multi-mode dispersion, and which is not suitable for the long distance communication. By why? Because of here modes are more here. This is not suitable, and the core diameter is also more here. So that here in large distances, the signal attenuation is going to be takes place. Okay, that's why it is not suitable for the long distances. Only single mode fiber is applicable to send the signal for a long distances. Okay. Next is the on the basis of refractive index, two optical fibers are there. One is the step index, another one is the graded index. So you can go for the step index fiber, uh, the step index optical fiber. The refractive index of core and cladding are constant. Okay, core and cladding both are constant in step index. The light ray which is going to be propagating through it in the form of meridianal rays. Meridianal step index. See here, meridian. Okay, and which cross the fiber axis during every reflection at the core cladding boundary. This is the boundary. Okay, so this is the signal input pulse, and whereas output there is a attenuation is to be observed. Did you see it? Attenuation is that signal is proper signal is going to be coming out from this step index optical fiber. No. Why? Because of here the step index fiber which is sending signal is like this, but the output pulse is like this. Okay. So that is the case. So what is the cladding diameter here? 380 micrometers. Whereas the core is 200 micron. You can see here up to this core, and this is the outer one is the cladding. So index of the refraction. This one. Next is the graded index. So the graded index in this type, uh, you can have core has a non-uniform refractive index. This one, core. Okay, core has a non-uniform refractive index that is gradually decreasing from the center toward the core cladding index. So you can observe this gradually decreasing toward the this curve. This curve is indicating here. At the center is more. And if you go away from the core to the cladding here, the refractive index which is gradually decreasing. Okay. So what is the cladding is one here the refractive index which is here 125 micrometers and the diameter is, and whereas for core is 50 to 100 micrometers. Okay. So this is the graded index. Though, so here, which is the signal you are sending, you can see here how the output is going to be coming out. Okay. You can easily observe that input as the output here. Okay. So here the cladding has a uniform refractive index. Cladding is uniform refractive. Whereas the light ray which is going to be propagating through it, which is in the form of helical rays. This one. So they never cross the fiber axis. helical rays. So what it is, this is a single mode. You can see whatever the signal you are sending, the same signal which is coming out. In graded index, there is a small attenuation. In step index, totally. Okay. So what is an optical waveguide? So by using the waveguides only we are sending. So an optical waveguide is a physical structure that guides electromagnetic waves in the optical spectrum. So what are the common types of optical waveguides, and which is including optical fiber and rectangular waveguides are there, and optical waveguides are used as a component in integrated optical circuits or the transmission medium in local long haul in optical communication systems. So these are classified according to their geometry, that means a planar, strip, or fiber waveguides. In mode structure, single mode is there, multi-mode is there. Refractive index distribution is step index, graded index. And materials, what are the materials we are using to prepare these waveguides means there should be a glass is there, polymer is there, semiconductor is there. Okay. So you can observe here, this is an optical fiber. In this only electromagnetic waveguides means this may be including here, this one. So types are there. Plane waveguide is there, rectangular waveguide. This is optical fiber in this. Next, this is the Gaussian effect, but we are not discussing in our syllabus. Okay. So this ends our optical fiber. So the thing is that here, uh, what is the main important essay question means here? Uh, this is the whether it is a step index or graded index, whatever. Right? So you can go for it. Classifications. So the classifications is this one: step index, graded index, and based on the mode, single mode, multi mode, based on the refractive index, step and graded, based on the materials. All glass fibers are there, plastic fibers are there, glass core with plastic cladding fibers, polymer clad silica fibers. So this is the step index. So refractive index, step index single mode, step index multi. How the transmission, this is the total internal reflection. So first internal, second internal reflection, like that. These are the graded index. Single mode, multi mode. Acceptance angle. What do you mean by acceptance angle? Acceptance angle, which is defined as the maximum angle of incidence at the interface of air medium and core medium, for which the light ray enter into the core and travel along the interface of the core and cloud. Once again, acceptance angle is the which is defined as the maximum angle of incidence at the interface. Interface means two medias which are to be separating here. One is the air medium, another one is the maybe the core medium. Core is the denser medium, for which the light ray enter into the core. That means the refraction is to be takes place and travel along the interface of the core and clad. So this is called acceptance angle. Okay. So let me give you one thing is that N naught, N1, N2 be the refractive index of the air, core, and cladding. So let OA, which one? This one. OA is incidenting at the interface here. This one of the air media and core media with an angle of incidence is theta naught. Then the ray refracts into the core medium. Refraction is to be takes place. Air to denser means toward the north. Denser to air means away. So refracts into the core medium with an angle of refraction is theta 1. And AB is the refracted ray incidenting on the interface. This is the interface here of the core cladding with an angle of incidence is 90 minus theta 1. This is 90 degrees minus theta 1. This may give sense. So if 90 minus theta 1 is equals to the critical angle of core cladding media, then multiple reflections is to be takes place. The ray travel along the equals to means along the core cladding only the ray which is path moving. If it is greater than multiple reflection, internal reflection. If the less than means here the angle of incident at the interface of the air and core, which is theta 1 is less than theta t. Then 90 minus theta will be greater than the critical. So that in this case, total internal reflection is to be takes place. So according to the Snell's law, we are doing the calculations n naught theta naught equals to n1 theta 1, theta naught equals to n1 by n naught into sine theta 1 by using the Snell's law at point B same. In place of theta naught, that is that 90 minus theta 1 is sine theta 2 is 90 degrees. Substituting, you will get the sine theta 1 equals to square root of 1 minus cos theta. So by simplifying, you will get the theta naught is the acceptance angle, which may gives out the sine inverse of square root of n1 square minus n2 square by n naught. So this is very, very important essay question, acceptance angle. What is the numerical aperture? Numerical aperture, which is defined as the light gathering capacity of an optical fiber. Okay. And it is directly proportional to the acceptance angle. So if more acceptance angle increases, then the numerical aperture is also going to be increased. Or else NA is increases, acceptance angle is also going to be increased. So NA value is N1 into square root of 2 delta. So how we are using in communications, waveguides. So this is the we are using in communication system, encoder, transmitter, waveguide, receiver. So differences they may be asked, step index and graded index. These are the differences. And another difference is a difference between single mode and multi mode. This is the case. So what are the advantages of the fiber optic? Short question, which is having enormous bandwidth. If the bandwidth is more, you can easily carry the and transmit the signal uh, with a high with the frequency of the transmitted signal for a long range. Okay, so for low transmission loss, the signal strength is attenuation is also going to be removed, and the loss of the signal is also going to be removed. Okay, easily whatever the signal you are sending, that much of the signal you can receive at the other end while you are using these. And electric isolation. These are the insulators here. fiber optic material, and these are not going to be exhibit the earth and interface problems, and also communicate through the fiber even in electrically dangerous environment. And signal security, small size and less weight, and low cost, and immunity cost. What are the applications? Applications of the fiber optics is more. This is another short question, which are extensively used in the communication systems, and these are exchange of information between the different computers, and exchange the information in cable television, space vehicles, submarines, industry and security alarms, process control and industrial automation, which is used in pressure sensors in biomedical and engine control, and also used in fabrication in endoscopy for the visualization of internal parts of the human body. Nowadays, we are using. Okay. And sensing the applications of optical fibers, which is a displacement sensor, fluid level detector, liquid level sensor, temperature and pressure sensor, chemical sensor. Most of the sensors we are using in engineering applications. Uh, what is the principle behind this means here only fiber optic. And medical applications in most of the cases. Whereas in gastroenterology, that is a gastroscope or arthroscope, and and cord scope, and uh, peritonoscope, and fiberscope. So many medical applications. Yeah. Okay. So this ends our fiber optics. Only one is left out, that is lasers. In lasers, you can go for the helium neon laser. Okay, na? So time is up. But the thing is that here you need to go for the thoroughly. You can prepare from the textbook only, so that which can help you more. And also so many books which are available in the market related to the topics here. You can go for that. Okay. Right. All the best. So signing.